Okay, here I'm going to go over some basics of soil. And while initially you may think this is an area where kind of worms live, keep in mind that there is inorganic mineral matter that composes 75%, typically 5% organic matter, which contains microorganisms and macroorganisms, and then 50% of it is actually defined as air and water. This is what makes up soil. So again, what is soil? Well, it's mineral-based material that also contains air, water, and organic matter. A lot of times people, I think, get hung up on the organic matter. Keep in mind air and water are also vital components there. Good for growing plant conditions, 25% air, 25% water, 50% solid. Compacted soil. This is where we're kind of squeezing out some of that air, still retaining 25% water, but increasing that solid percentage. Poorly drained soils, we also have that 5% air. We have increased that water amount quite a bit. So while the solid is still 50% here, that matches the good growing conditions. In this case, we have an excessive amount of water, suffocating those roots, reducing plant performance. Particle size. So the size of particles determines the classification due to the impact on open space between those particles. Most soils are a mixture of different particle sizes. Clay is defined as less than 0.002 millimeters. See, it's the smallest of the particles. Gravel is the largest, 2 mils to about 75 millimeters. Sand and silt and clay are going to be the three we're going to kind of focus on here. Silt is that 0.002, so from basically clay up to 0.05 millimeters. And sand would be larger, that 0.05 to about that 2 millimeters. You can see just in comparison, while we may think of sand particles being very small, it is clay that is actually the smallest. And again, how do those look? Well, we have clay soils, we have sandy soils, we have loamy soils here. So clay being comprised of those smallest particles, and then loam kind of being in the middle, and sand being the largest. Well, clay soils contain the small soil particles, and they have a tendency to pack together, reducing air spaces. Greatest amount of surface area, and they have a great impact on soil properties. This soil will crack when dry and a tendency to stick to equipment. And if you've ever worked with clay in like a pottery class, it has a very similar consistency in extreme cases to something like that. And we kind of see here where we're having that stickiness appearance here, that sheeting that occurs. This would be very indicative of a clay or very, very small particle-based soil. Field tests to determine clay. Simply take a sample of the soil in your hand, add a little water, and try to form a ball, as we see here, and then attempt to squeeze the ball into a flat ribbon. If the ribbon reaches about 2 inches long or more before breaking, this is a sign you have clay soil, because those small particles are able to hold themselves together, and this is kind of one quick way, not a 100% accurate way, but a quick way to give you an idea of, does that soil contain a lot of clay-based particles. Sandy soils, they're the largest of the soil particles. It's very easy to cultivate in sand, however they tend to dry out quickly and can be easily flushed of nutrients. So while they can support plants, because of their large particle size, typically water can drain through them, and so can nutrients. So that's why I typically don't see a lot of plants being grown in desert regions where it's all sand, simply because of the low rainfall and the tendency for this soil to dry out anyway. Loamy soil is a combination of particles of about equal parts, which is about 40% of sand, 40% of silt, offers many properties that supports plant growth. It can hold nutrients, which is great, while still allowing water to percolate through and air to infiltrate, which is great. However, there's a large range of loamy soils. Kind of see 3 different subsurface areas of loam here. The dark brown is the fine kind of sandy loam. The subsurface layer is kind of this pale brown, is like this kind of also along those sandy-ish loam lines. And the red clay is a red clay loam. So you can kind of see some variability that does occur, but in general, loamy soils do favor crop development. The soil triangle, so it's important to be able to read this. Just on an initial kind of overview take, you can see that clay has a great influence, but you'll notice there's of course 3 sides to this triangle. And how we would go about reading that is if we had a soil that had 30% clay and 30% sand. So we take that 30% line, go over here, see where it intersects our 30% line right here. So 30 and 30 here, and 30 would be 60. 40% would have to be silt. See this line that comes down here. All 3 intersect right at this point here, indicating that soil would be a clay loam. So again, you would take your 3 percentages of clay, silt, and sand, and wherever those intersect would give you the soil type. And you'll notice that clay, again, because of its small particles, high surface area, has a great influence on the type of soil it may be classified as. Sand, very difficult to be considered a fully sand soil, and you can see those loamy soils are kind of here. So there's a true loam, here's a clay loam, sandy clay loam, all these different forms of classification, but you can see how you can kind of read this soil triangle. Lastly, you don't want to use soil if you're growing in containers. So you don't want to just go out and dig a bunch of soil, put it in containers, and go grow in it. This isn't advised. It's often heavy in mineral base, which can lead to issues utilized in indoor operations. The water holding properties are not conducive to container growing. Outdoor soil is great for outdoor operations. But just because plants may grow good outdoors doesn't mean that will translate into the high stress environment of indoor container gardening.